when you're working out number of moles of something? Okay, we know the two equations. What are the two equations? Little m over big M and? Nope. P is equal to, or P over, N is equal to P over? Not avocado's number, but yes. All right, so that's the number of moles. However, you really need to think about something else, is that if I have something like calcium chloride, right? If I have 1 mole of this, right? You've got to remember that this is calcium 2 plus and Cl minus, but there are 2 of the Cl minuses. So if I was asked to say, okay, calcium 2 plus and Cl minus, how many moles of calcium 2 plus would I have? How many moles of it would I have? Okay, let's go through a different example. I have, look at my beautiful drawing skills. I'm a car salesman. I have 100 cars. That means how many seats, actually no, let's do seats. Let's do wheels and steering wheels do I have? How many wheels do I have if I have 100 cars? 400. How many steering wheels do I have? How many steering wheels per car, sir? Okay, so are we happy that from 100 cars, we've all of a sudden got 500 things? We've got 500 things from 100 cars. Good. So if I had 100 particles of the CaCl2, and it's really not particles, but anyway, yep, 100 of the CaCl2, how many Cas do I have? 200, incorrect. 100, because there's 1 Ca for every CaCl2. How many Cls do I have? 200. Are you happy that all of a sudden I turned 100 things into 300 things? Because what am I doing? I am splitting them apart. Does that make sense? And when you split stuff apart, you end up with more of that stuff, just in smaller bits. Does that make sense? All right. So that means that if I had, say, aluminum sulfate. What's the formula for aluminium sulfate? Go, I remembered all of the ions. I can tell you that in the test that there are multiple circumstances where you're just going to get a name like this and you're going to have to work out its formula. No, it's not a PO4.
SO42 minus.
Oh, it's an SO42 minus, that's useful. Is that what it is? Brackets. Okay. Listening, I am very, very serious. If you cannot take a name and turn it into a thing, that's the one you should be working on, because that's generally the first step in a larger process. And if you can't get the first step right, it makes it very difficult to do the rest of it. Okay, so if you just can't take a name and just immediately tell me its formula, really, really practice just do this. Just randomly pick one from one side, one from the other, and then give it a go. All right? So, aluminium sulfate, if I have 2.6 moles of it, how many moles of Al3 plus and SO42 minus ions will I have? So how many for Al3 plus, how many? 5.2 moles. Are we all happy with how they got 5.2 moles?
Yeah.
Excellent. Explain how they got 5.2 moles.
Times 2.6 by 2 over 1.
Why did you times it by 2 over 1?
Because it's the unknown over the known.
What's the unknown?
The unknown is the is the aluminium.
Mm-hmm.
Like how much
Yeah?
there is in ratio.
Okay, so like you're applying the stoichiometry idea, which is correct because the stoichiometry idea is effectively just a ratio. So what you would really say is that there is a 1 to 2 ratio for aluminiums to aluminium sulfates. So for every aluminium sulfate, there is 2 aluminiums. So therefore, if I have 2.6 moles of aluminium sulfate, I have 5.2 moles of aluminium. And like you can actually absolutely use that unknown over known stuff if you really if you want to. But yeah, that's what you're actually doing. It's fine. Like it's just different ways of wording it. Okay, and then how many moles of SO4 do I have? How many moles of SO4? I can math. Happy with that? 7.8. Quick math. Yeah? So, are we happy with that? What's the total number of moles of ions that I have then? Total moles of ions. 13 or 14? Yeah, we can math. 13 moles of ions. Stop. All right. So, then we can even go further. How many moles of atoms do we have? Or how many atoms do we have here? So how many atoms here? And we would say atoms is generally the number of ALs. How would we do that? What would we do? What's the calculation? How do I get the number of particles? Remember from the one before. The number of particles is equal to the number of moles times what? Avogadro's number. Are we happy that we can rearrange this equation? Yeah? Happy we can rearrange that equation? Then good. Then tell me what that equation is rearranged when this is the number of P. This side here is effectively the number of P. What times Avogadro's number? The one that you can't see, the number of moles, 5.2. Okay. This Avogadro's number is in your data sheet. So take out your data sheet, just in case so you don't have to actually memorize it. It is in your data sheet. It's on the second page at the top left under constants.
It's too late, I've already memorized this.
And also the other equations are there as well, yes. Okay. Under constants on the second page in the top left. Second page, top left, constants. Okay, so that number is there, but let's wait, let's keep on going. How many sulfur atoms will I have here? 7.8 times what? 0.22 times 10 to the 23. And then how many oxygen atoms will I have? Nope. Times by 4. Times by Avogadro's number. Why do I times it by 4, Lauren? Because I have 4 oxygens per that SO4, for every SO4. Right? So you could really want to, if you wanted to, work out the number of atoms of each thing, or you can work out the number of ions, depending on what you're asked to solve for. Okay? So that's just the ratio of things. But I really don't want people to do is being like, okay, well, this is what a lot of people do when they're not sure of what to do. Let's just change that to 2.5 to make it a bit easier for this to be thing. All right? 2.5. People will say that, okay, there are 5 ions here. So therefore, out of the 2.5 moles, 2/5 of 2.5 is equal to 1. And that's the number of moles of aluminium. And then 3/5 times that 2.5, which is the 1.5 mole, is sulfate. Now that is wrong. Yeah? That is very wrong. It's the idea that you can't have more than 2.5 moles of stuff if you started off with 2.5 moles of stuff. But remember, we are not conserving this, we are splitting it in parts, so we expect the number to get bigger. It's like when you ask how many parts of there are there, you expect the number to be bigger than the number that you started with. But a lot of people will just be like, no, I can't be any higher than 2.5. And it's especially true when you get like things like that are easier when you get like NaCl. NaCl, if I have 4 moles of it, that people will think, oh, okay, I got 2 moles of Na and 2 moles of Cl. But that is not correct. Okay, so that is not correct. Don't think like that. You've got to remember that you're splitting it apart. You'll end up with how many moles of each? 4 moles of each. Okay? Happy with that? You are splitting it apart. Okay, cool.